Simplify the expression. We have 6x to the third times y squared, all that to the 1/2 power, then plus 3y times 216x to the third, all to the 1/2 power. So if we're going to add these, we need to change how they look a little bit and see if we can make it so it has the same variable parts. And it looks like what we want to do is we want to see if we have any perfect squares we can take out of the radical for the 1/2 power. Because remember, 1/2 power is the same as the square root. So I'm going to rewrite it as 6 times x squared times x times y squared to the 1/2. And that's the first part. And then plus 3y. Okay, now 216 is 6 to the third power, so I'm going to write this as 6 squared times 6. And then x to the third can be written as x squared times x. And then that to the 1/2 power. So now the perfect squares are going to be taken out of the parentheses with the 1/2 power. So the x squared is going to come out and the y squared is going to come out. So it's going to be x, y, and then in parentheses is going to be 6x still, and then to the 1/2 power, plus, and let's look at this guy, the 6 squared can come out as can the x squared. So it's going to be, so you take out the 6 squared, that's really just going to be a 6. It'll be 3y, and then times 6, and then times x, and then in the parentheses is the 6x to the 1/2 power. Now let me simplify this a little more. The first term is going to stay the same. Now 3 times 6 is 18, and then xy, and then times 6x to the 1/2. So let's look now. The variable parts are the same. They're both xy times 6x to the 1/2 power. So we have 1, invisible 1, let me write that in, and then plus 18, so that's going to make 19, and then it's going to be xy times 6x to the 1/2 power. So now that expression is simplified.